Early mechanical computers, pre-19th century. The concept of mechanical computing can be traced back to ancient times, with devices like the abacus, ca. 3000 BC, used for basic arithmetic. Later, in the 17th century, inventors like Blaise Pascal and Gottfried Wilhelm Leibniz designed mechanical calculators that could perform addition and subtraction. The analytical engine, 1837. Charles Babbage, an English mathematician, designed the analytical engine, a mechanical general-purpose computer that used punch cards for input and output. Although it was never fully built during his lifetime, it laid the foundation for modern computer concepts. The tabulating machine. Late 19th century, Hermann Hollerith developed a tabulating machine that used punch cards to process and summarize data. This machine was used for the 1890 United States Census and later formed the foundation for IBM. Vacuum tube computers, 1930s–1940s. The first electronic computers used vacuum tubes as switches. In 1937, Howard Aiken completed the Harvard Mark I, a massive electromechanical computer. In 1944, the Colossus was developed in the UK to crack German codes during World War II. The ENIAC, 1946. The Electronic Numerical Integrator and Computer, ENIAC, was the world's first general-purpose electronic digital computer. It used over 17,000 vacuum tubes and paved the way for faster electronic computing. Transistors and miniaturization, 1950s–1960s. The invention of the transistor in 1947 revolutionized computing. It led to smaller, faster, and more reliable computers. In 1958, Jack Kilby and Robert Noyce independently invented the integrated circuit, IC, enabling further miniaturization. Mainframes and minicomputers, 1960s–1970s. Companies like IBM started producing mainframe computers that served multiple users simultaneously. At the same time, minicomputers emerged, offering computing power to smaller organizations. Microprocessors and personal computers, 1970s–1980s. The development of the microprocessor in the early 1970s brought computing power to a single chip. Companies like Intel and Motorola led this revolution. In 1975, the Altair 8800 was released as the first commercially successful microcomputer kit. The 1980s saw the rise of personal computers, PCs, with the launch of the IBM PC in 1981. Graphical user interface and the Internet, 1980s–1990s. Xerox PARC developed the first graphical user interface, GUI, in the 1970s, which later influenced the creation of the Macintosh by Apple in 1984. The World Wide Web was born in 1989, leading to the Internet's explosive growth and changing the way people interact with computers. Laptops, smartphones, and tablets, 1990s–2000s. The 1990s saw the emergence of portable computers, including laptops, which became increasingly popular. In the 2000s, smartphones and tablets revolutionized personal computing, providing compact devices with powerful capabilities. Cloud computing and big data, 2000s–2010s. Cloud computing became prominent, allowing users to store and access data and applications remotely. The rise of big data and data analytics transformed how organizations process and utilize vast amounts of information. The future of computers. Artificial intelligence, AI, and machine learning will continue to advance, enabling computers to perform complex tasks, learn from experience, and make decisions autonomously. AI is expected to impact various fields, from healthcare and finance to autonomous vehicles and robotics. Quantum computing. Quantum computers have the potential to solve problems that are currently intractable for classical computers. They will accelerate research in fields like cryptography, drug discovery, and climate modeling. Internet of Things, IoT. The IoT will connect an ever-increasing number of devices, creating smart homes, cities, and industries. Computers will play a critical role in managing and analyzing the vast amounts of data generated by IoT devices. Edge computing. Edge computing aims to process data closer to the source rather than sending it to centralized data centers. This approach will reduce latency and enable real-time processing for applications like autonomous vehicles and industrial automation. Biocomputing and neuromorphic computing. Biocomputing explores using biological molecules to perform computations, while neuromorphic computing mimics the structure and function of the human brain. These approaches could revolutionize computing capabilities. Extended reality, XR. XR encompasses virtual reality, VR, augmented reality, AR, and mixed reality, MR. As XR technologies advance, computers will play a pivotal role in delivering immersive experiences across various industries. Supercomputing and quantum internet. Supercomputers will continue to push the boundaries of computational power, while the development of a quantum internet may enable secure communication and computation between quantum devices. Ethical and privacy concerns. The future of computers will also be shaped by ethical considerations, such as data privacy, algorithmic bias, and the responsible use of AI. As technology continues to evolve, computers will become more integrated into our daily lives, transforming how we work, communicate, and interact with the world around us. While the future is full of possibilities, it's essential to address challenges and ensure that technology benefits society as a whole.